Assalamualaikum and greeting everyone. First of all, I would like to say thank you to my supervisor, Associate Prof. IR Dr. Ahmad FARID ABIDIN, my panel, Prof. IR Dr. ISMAIL MUSIRIN and Dr. KANENDRA NAIDU anak lelaki VIJYAKUMAR, and to my FOP2 coordinator, Sufma Abdulatif. Welcome to my final year project presentation. I am Muhammad Hazmi Bonase, a final year student in Bachelor of Engineering, Honours Electrical Engineering. The title of my FYP is The Analysis of Voltage Set Source Location Under Distribution Network and Distribution Generation. Okay, let's get started with the background of the study. What is the voltage set? Voltage set is described as a rapid drop in RMS voltage, the value between 10% and 90% of normal voltage in less than a minute. It is one of the electrical power system quality issues. Most common cause of the electrical voltage set is a big induction motor starting, short circuit problem in the network, and the load shift from one source to another. To prevent the voltage set condition become worse, there are many studies conducted to analyze the location of fault. One approach of the study is conducted by locating fault by analyzing the parameter of fault. The voltage set are described by parameter of both magnitude and phase angle in analyzing the voltage set characteristic. In this study, the main challenge faced by researchers is locating the set source, and they've discovered that the relationship between the recorded voltage and current throughout the set may be used to detect the set cause. However, there are no studies done yet on which control method that can give the best result to locating the set source in distributed generation condition. Okay, to overcome the problem, there are two main objectives in this study. First is to study the voltage set characteristic and simulate the system to locate the set source in Malaysia. The technique for detecting voltage set and the data obtained by using the MATLAB SIMULINK software. Next, to develop the best method based on the locating voltage set source for distribution generation. Okay, next for the proposed method in this research is voltage set magnitude, phase angle jump, RMS evaluation method, and the type of DG used in this study. Okay, first let's go through to the voltage set magnitude. The most popular method to obtain the set magnitude is to use RMS voltage. As a result, the magnitude of the set is the residual voltage or remaining voltage throughout the set. In the three-phase system, the minimum RMS voltage during the set may also be used to calculate the voltage set. The fault type and resistance, the distance to the fault and the system layout have a role in the magnitude of set at any given location in the system. A point of common coupling, or called PCC, located between the fault and the load is necessary to determine the set magnitude for a fault somewhere in a radial distribution system. Figure below show the voltage divider model. ZF is the impedance between the PCC and the fault, while the ZS is the source impedance at the PCC. The voltage set at the PCC equal the voltage set at the equipment terminal and can be found by using this formula. We assume that the voltage before the accurate is exactly 1 pu, thus E equal to 1. Okay, next for the phase angle jump. A short circuit in the power system causes a drop in voltage magnitude and phase angle. The phase slip is seen as a shift in the zero crossing of the instantaneous voltage. The source of phase angle jump associated with voltage set from figure below may be utilized to understand the single phase voltage divider model. Let's assume Zs equal to Rs plus ZSS and ZF equal to Rf plus JXF are the source and feeder impedance respectively. The phase angle jump in the voltage is thus provided by the formula below. There is no phase angle jump if Xs divided by Rs equal to Xf divided to Rf. However, if the X over R ratio of the source and feeder are different, the phase angle jump will be present. Okay, after that, the RMS evaluation method can be calculated in various ways. It is better to calculate RMS voltage than calculate its magnitude and phase. Therefore, it is easier to analyze and commonly used in power system analysis. The two important examples are the magnitude of the fundamental component of the voltage and the peak voltage over the cycle and half cycle. It has no difference whether the set magnitude is calculated using RMS voltage, fundamental voltage, or peak voltage as long as the voltage is sinusoidal, because of the RMS voltage, which is related to power calculation and the best for calculating the magnitude of voltage set. Okay, lastly, for the type of DG used, it can be classified into 4 general types. First type is DG is capable of injecting P only. Second, capable injecting Q only. And third, capable injecting both P and Q. And fourth, capable injecting P but consuming Q. For the photovoltaic, microturbine, and fuel cell are in the good example of type 1. Type 2 could be synchronous compensation such as gas turbine, and the synchronous machine gas turbine fall in type 3. Type 4 is mainly induction generator that are used in wind farm. In this paper, we consider only type 1 distribution generation to analyze the voltage set with the distribution generation system installation. Okay, next for the process of the study, start with the develop of the distribution system. Next is to create the fault of single phase to ground and the 3-phase fault before and after the transformer. Then run the simulation to obtain the voltage, magnitude, and the phase angle. After that, the DG is installed into the distribution system and the same type of fault is used and create before and after the transformer. Then the simulation run again to obtain the new data for the voltage, magnitude, and the phase angle. Lastly, the result conventional system obtained will compare with the DG system. Okay, for the developed distribution system, the system starts with the 11 kV source with the 50 Hz frequency. Then the RL serial bus is connected to assume as the short transmission line. Next, the distribution system is stepped down to 11 to 0.4 kV with delta 1 transformer. After that, the RL load is connected to assume as a short transmission line as the voltage drop to 230 volt. Furthermore, the 3-phase parallel RL load is connected at the end of the system with parameter of active power 10 kW and inductive reactive power 4.16 kΩ. In this study, there will be 2 conditions of fault to simulate. First condition is simulating the single line phase fault, and the next condition is under 3-phase fault. Then, the type of DG used in the system is PV type with 88 parallel string and 7 string series connected. The output voltage of the DC under PV is 560 volt, and IGBT inverter will use to convert the output voltage of PV to the output voltage RMS for AC is 400 volt. Then the Y ground and Y ground transformer will connect the DG from the DG to the distribution system. Lastly, the fault is simulated after the DG is installed into the system. Okay, for the result and analysis section, this part consists of the result system without fault, next the result of single phase to ground fault, and lastly 3-phase fault. Okay, for the system without fault, the difference between the condition distribution system without and the with DG have been shown in the table. As the result, for the bus source, the identical result have been achieved under the RMS voltage without and with DG installation. However, the value of the current was increased by the 30 amp when the DG is installed. Furthermore, there are significant difference of current under the bus 230 volt when the DG is installed, which is increased from 21.8 amp to 206.9 amp. The value of RMS under the load bus is dropped from 238.1 volt to 146.3 volt when the DG is installed. In addition, for the phase angle, they are slightly increased under the bus source and the bus 220 volt when the DG is installed. Okay, then for the load bus under the single phase fault, the voltage RMS is same with the bus 230 volt without DG. Next, when the DG is connected to the distribution system, the voltage RMS is slightly decreased 200 to 150 volt. For the phase A, the voltage is dropped from 112.6 volt to 74.5 volt under the first set. In the second set, the voltage for phase A is dropped from 131.6 volt to 84.5 volt. This shows the significant decrease of voltage when the DG is installed into the distribution system. The current of system under the DG is reduced to 10 amp. Meanwhile, the phase angle without DG is average around 20 degree when the digit is connected to the phase angle remain the same. Okay, in this condition, the three-phase fault system is created into the distribution system and recorded into the table. The voltage of RMS of bus 230 volt and load bus under without and with DG is below of to 100 volt. While the phase angle for phase A load bus, the value changed from 21.9 degree to 9.4 degree in first set. The current of the bus 230 volt and blood bus are below than 100 amp for each phase under the three-phase fault. Okay, in conclusion, the best method that can be utilized is RMS voltage evaluation and the phase angle for locate set source without and with DG in distributed system. This technique are considered the best as it can reduce time in finding set source and fewer calculation needed. This MATLAB SIMULINK has been used to simulate the real situation of the power system and the fault condition. The result obtained that the distribution system with DG give different outcome compared to the system without DG during the voltage set. Hence, the objective is to study the voltage set characteristic and simulate the system by develop the best method based on locating voltage set source for distributed generation has been achieved. For the future study, DG Type 3 can be utilized to mitigate the set source as Type 3 capable injecting real and relative power to the system. That's all from me. Thank you.